Okay, hi. I'm going to give you the start of my puzzle here. I just want to do this for you so that you can get the general idea. And so this is mainly for Didio Yakudo. I don't know how to say your name. Anyway, because you gave my puzzle a try, and I'm really, really thankful for that because you're one of the only ones who has given it a go, and so thank you very much. All right, so as I said in the, let's just quickly go through the rules again. Shade some cells as hot. So the way I'm going to do that is I'm going to just pick those cells and I'm going to go with that as hot. So if those are hot, that's hot. Then I've got to rotate those cells 90 degrees, and all of those cells get rotated 90 degrees and become cold. And a 90-degree rotation, which that rotation is going to be kind of complicated, would be those cells. Those cells will be cold. Yeah. All right. Now, if for whatever reason I determined that this cell was actually hot, well, I could just leave it like that. It's mixed blue and red. I think that's sometimes easier to see. In fact, you know what? I'm just going to go ahead and make that this one so you can clearly see. I think that's easier to see some ways. So you can see that that is a mixed cell, both cold and hot. Therefore, it's lukewarm. If you prefer to make that a different color, like green, I may do that if I feel like it's useful. But yeah, sometimes it's just easier just to go like that. It's mixed red and cold, hot and cold, and that's why it says when hot and cold cells overlap, these cells are lukewarm. Okay, low digits have to be in low digits of 1, 2, 3 have to be in purely cold cells. Now, although these are cold, they might not be purely cold. So yes. Lukewarm cells must be, so that one must be a 4, 5, or 6. It's a mix of blue and red. It is now lukewarm. It's a 4, 5, or 6. And these may be purely hot, but they might also be mixed with blue, so we don't know yet. 7, 8, or 9 for purely hot cells. Okay, so let's get going. The rest is pretty straightforward. Now, I think a lot of people would start here, and as you did, I'm pretty sure. Also, this is pretty easy to figure out up there, so we'll do both. All right, here. So this cell here, let's have its basic value. That's 1, 2, or 3 at a minimum. This is going to be, well, that's going to be 6, so this is going to be a 3 maximum to make 9 here. But considering that's a 3 and that's at least a 1, that's going to be a 7, 8, or 9, and this can be up to 2 or 3, and we're off and racing. Now, these don't have to be 1, 2, or 3. They're a minimum of 1, 2, and 3. We'll get back to that. But we'll see that there are other options. We'll be able to figure out some other stuff here. Now, considering that that's at least a 7, it is at least a purely hot cell. And therefore, rotationally, this will have to be a cold cell. We'll put a cold cell there. Now, at this stage, we don't know if that's, let's just fill in the details. It's 1, 2, or 3, but it could be middly as well. So it's definitely not purely hot. We know it's not purely hot. So it's at least cold or middly. So 1, 2, 3, 4, 5, or 6. I mean, we know it's not some of those numbers, but that's the general idea. Okay, let's have a look at this cell. He's cold. 100% cold. In fact, pure cold, which meant this cell here had to be at least in some ways hot to get this to be cold. So this is hot. Now, it's not purely hot necessarily. It could be 4, 5, 6, 7, 8, or 9. Because it could be mid. There could be a cold digit coming from a hot cell here to make that cold, making it middly. All right, but it itself is red, and yes, to make that blue. Okay. Now, some more advanced techniques. What's that cell? Well, we know that there is no red there. There is never going to be red. This is not going to be middly ever. This is never going to be middly, or it's certainly not going to be pure hot. Therefore, how can that have any blue whatsoever? The answer is it can't. And it has to have a digit. We can't just leave it blank. So what digit's it going to have? Well, it's going to have, oops, it's going to, still screwing up there. It's going to have 7, 8, or 9 in it. It has to, which makes it purely red. Okay, and that being purely red means that this one is at least in some ways cold. Now we haven't looked up there, so we'll mark it as 1, 2, 3, 4, 5, or 6. But actually, you'll see that these are identical to these up here. So whatever we do here, we can do up here in a second anyway. Okay, let's look a bit closer at this. And what we can determine is that I think none of these could be 6. 6 plus 6, and then a 1, 2 pair, that would be 6, 7, 8, 9, and that would make 10. So none of these could be 6. So let's get rid of 6 out of that. Okay. Now this on a dot though can't be 5. And yeah, that leaves us our available digits. And I think that's right. So considering this is on a dot with this, this would be normally 1, 2, 3. Wait, it can't be 3 because that's not a 6. Could be theoretically a 6, and an 8. But we've already discussed before. It can't be a 6 or an 8. It's just not possible. That would bring these digits up for that total to be too high. So I think that's a 1 or a 2 only, which means since this one can't be a 6, that one actually can't be a 3. Now this still could theoretically be a 4, which we haven't sort of eliminated yet. I think, yeah, you got to realize that. But it is, now we've eliminated that one down to a purely cold cell. Excuse me. Yeah, so this is purely cold. Let's think about how this got cold in the first place. It must have got cold from that one being hot. 4, 5, 6, 7, 8, or 9. But this being purely cold, which we've now figured out, it casts this as purely hot. For the same reason that made that purely hot. This one being purely cold means that one, what else is it going to be? Let me restate that logic for you again. This one cannot have red in it anymore, so therefore it can't make that one blue in any way. So it must be purely hot, because every cell needs digits, and the rules state that all of these digits must appear in either cold or lukewarm or purely hot cells respectively. That means the whole grid must be filled out with color, because all digits must be in a color, must have a cold or a lukewarm or a hot. So what color is this going to be? It has to be 7, it has to be hot, it has to be 7, 8, or 9. That's the only possibility for it. Now, like I said before, this whole logic up here, so this whole logic here can be repeated along here. So I'm just gonna, well, nearly, with the exception that there's no, with the exception that there's no blue cell, sorry, no crop T dot here. So this one actually has to be 7, 8, or 9, which makes it interesting, because how could this be 4 now? This one can't be 4. If it was 4, it would be a mixed cell. It would be a middly digit. But then that would be hot, and then that would push a cold here where it can't be. So this can't be 4. This is a 1, 2 pair. There you go. Yeah, I think you had that. So this is 7, 8, or 9 here and here. This is good. Let's look at these. These can be 1, 2, 3, 4, or 5. They can't reach 6 for the reasons stated below. Actually, noting that these, actually, if I recall, yeah, this one couldn't be anything but low. Purely low. 1, 2, 3 at a minimum, 6, 7, 8, 9. Yeah, this can only be 1, 2, or 3. Now this pushes this for the same reason that I've talked about before. This causing that to be purely red, purely red. This one will cause this one to be purely red. It rotates that way. What could this otherwise be? If that one cannot be red, I'll state it for the third time. That one cannot be red anymore. Therefore it cannot make this one blue. And if it can't make it blue to be middly, the middly digits are out. That's a 7, 8, or 9. Okay. These, what I can say is that these are at least blue. Yes, they could be red as well, but they're at least blue. So how did they all get blue? Well, they all got blue from that one, from all 3 of these being red. This one we're not so sure about. He could be 4, 5, 6, 7, 8, or 9. Because he doesn't have to be purely red to make it blue. Just has to be somewhat red, somewhat hot. All right. Now, yeah, that's generally how we That's how we get started. I think you probably looked at this one. This is pretty straightforward up here. Yeah, let's do it. 1, 2, 3. This is a 3 croppy dotty thing. We, if you're familiar with that, we know that this is 1, 2, 4, or 8, which is pretty good. But can we have? Well, we can't have 2 and we know we can't have 2 and 8. No, wait. We can't have 2 and 8 because that can't be 10. So can this be 2, 4, 8, or 4? Can it be 2, 4, 8, or 8, 4, 2? Which 8, 4, 2, 2, 4, 8. No, this one can't be 4. So actually, this one can't be 2. That one can't be 2. Is that right? It can't be. You can never have 8 in the middle. You cannot have that. That's a 2 in the middle. Yeah, 100%. That's a 2 in the middle. And then what goes either side of it? 1 and the 4. Yeah, these can't be 8. Oops. 1 and 4. We actually get. We actually get all those as blue cells. 1 and 4 is 5. This is actually just a given. It's such an easy given. That's completely middly. So we'll mark it as hot and cold because that's what it is. But now think about the what's going on here. These all being at least somewhat cold mean all of these are at least somewhat hot to cause that to be the case. Same with this one. This one is blue. This one is got cold. It's cold and hot, so which means that one needed to be hot, and this one needs to be cold from its hotness. From this one's hotness gives that its coldness. This one's hotness gives this one its coldness. Okay, so we could mark up all those cells, but yeah, might as well. 1, 2, oops, not 1, 2, 3. 4, 5, 6, 7, 8, or 9. It looks like these can't be 5, obviously. And now, once again, this is a 2. That's purely cold. That makes that one purely hot for the reasons I've stated several times now. This one being hot causes this one to be cold. We don't know the kind of coldness that it is. It could be just 1, 2, 3, 4, 5, or 6. And we are, yeah, we're well in business. Now this one here is 1, 2, 3, 4, 5, or 6, I believe. Take out the 2 as an option. Now, I think there is a way of disambiguating which way around these go. Yeah, there is. It's from up here. Yeah, we get the 5, 2 pair here. I forget which way you do this. But the thing is we know that there's at least this one. Yeah, hang on. I forget. I forget how you do this. Let's mark this one in. Now this one, I think this one has to have a 1 in it. Let's think about that. If there was 2, 3, and 4, that would be 7, 8, 9, and then that would make 10. So it has to be a 1 up here. There has to be a 1. That eliminates one of the possibilities up here, but there has to be a 2 in it. I forget how you get that. Yeah, I do forget how you get the 2 in there, but there is a way. To get there so that that's a 2. Oh yeah, that 1 makes that a 1. Yeah, that makes that a 4. Yeah, straight away. 4, that's a 4, which means it's got hotness, which means that one is now blue, a little bit blue from its hotness. So we'll mark that one. 1, 2, 3, 4, 5, 6. And then this one is a 1, and that means that's not a 1, that's not a 4. Yeah. All right. Now that's got purely 1. That's a purely cold digit, which makes that one a purely hot digit. It has to be 7, 8, or 9. This hot makes that one cold. Could be 1, 2, 3, 4, 5, or 6. We've eliminated 4 as a possibility, and now that we've eliminated 4, that's how you get the 2, I think. Because if we don't have a 2, what is it going to be? Well, there's definitely a 1. Then there's, 3 and 5 together make 8, plus the 1 is 9, plus whatever this is, you got too many. So there is definitely a 2 now here, which is really cool because for this Kropki dot, you have 3, actually, yeah, you got 3, 6 as a possibility, but I know you can eliminate that somehow. I forget how. Or 4, 4, 8. Yeah. 3, 6, or 4, 8. Forget how you eliminate the 3 and the 6. Oh, because Yeah, no, I forget. It will get eliminated, but yeah, I'm not sure how you do that. Just yeah, I forget. We could do this one as well. Let's do it. This one can't. This is nonsense. You can't have 9 here, or 7, or 6, or 5. That's a 4 or an 8. Now you eliminated the 4 somehow. I'm not sure how you did that, but that is not correct. But this one is a 2 or a 4, and this is a 1 or a 2. And that is the only possibilities. But these are at least somewhat blue. You can determine that. And the fact that they are at least somewhat blue, both of them, even if this is a 4, middly would be at least a cold, it means that these two are hot. And I think that's how you want to make the 3, 4 possibilities. Yeah, the 3, 6, none of these can be 3 anymore, because it would be none of these could be 3. None of them could be 6. That's a 4, 8. Now it's at least somewhat. Obviously there is a 4 here, which means one of these is also cold, but I'm not sure which one of them is yet. But yeah, that's a 4, 8 pair. Eliminates an 8 from there. I suppose it eliminates an 8 from there, and I suppose there's a 4 already eliminated there. And now pretty much you're well on your way now. There is a 2 here. You can eliminate the 2 from there. There is a 4 here. That does help a little bit too. I will mark that because it can help. And there's a 2 here. Just pay attention. There is a 4 here. It eliminates 4 from all of those cells. Yeah. Anyways, now let's consider this cell really quickly. This is another thing you can do. What have we got here? We got 3. Now I'm pretty sure we can go. Can't do another. We can do another 3, 4, or 5 theoretically, which means it's can't go up to 6. We already discussed that. It means it's at least a little bit blue, which means that one is red, at least in some part. Okay, this one here. Let's consider the options. I think I've done this before. I think we can eliminate 8 as an option here. Even though I think you eliminated another way. 3, let's say we went, how do we make, let's go 3 plus 3 plus 1. 3 and 3 is 6, plus 1 is 7. 3 and 4 is 7. Now that's how you do it. You got to eliminate the 4 from here somehow. Yeah, I forget how you do that. You would eliminate the 4 from there, and you know that it's not. Yeah, there is a way of eliminating the 4 from that. I'm pretty certain. There must be something else you could do before that. I think it might be something to do with this one. I forget. You do need to bring this one into it somewhere along the line. It does help. Let's do that real quick. Let's mark up the options. This one can't be 1 or 2, so it's 3, 4, 5, 6, or 7, or 8. So it's at least a 3. This one is 1, 2, 3, 4, 5, 6, 7, 8. No, it's not 8. Can't be 8. Can't be 7. There we go. Yeah, so this one gets you up to. This is an interesting one. So this one gives you up to 6, which means there's no red in it whatsoever. Sorry, there could be red in it. It's not purely red. It's at least somewhat blue, which means that this one here is somewhat. This one here, giving it its blueness, is at least somewhat red. 4, 5, 6, 7, 8, or 9, not 5 apparently. Yeah, so this is it. And then this one is 1 plus 3 is at least a 4. Let's have a look at that. 4, 5, 6, 7, 8, or 9. I think that's right. Yeah, because it can't be 1 or 2, so it's at least a 3. Plus that one is at least a 4. This one is at least somewhat red. It's at least a 4, which means it's at least somewhat red. It's not purely blue. Alright, with that one as red, we get this one as blue, which eliminates the 7 and the 9 possibilities, the purely red possibilities. This is 4, 5, or 6. Alright. Now, I'm pretty sure Yeah, there's some interesting interactions between these, and these, and then this. Oh, this, I think that's the issue. If this is a, no, I forget how you do this. If this is a 1, that causes that to be a 2. Yeah, I think that was it. 2, 4, and 8. All right, so yeah, going back to here, this is how you eliminate the 8, I think. Okay, so the only way that this could be an 8, I think, is if that's a 1. Think about this. 3 plus a 3 and a 1 gets you to 7. If that's a 3, look at this. If this is a 3, how can I get 8? 3 plus 3 is 6. This has no option of being 2, so you can't get to 8. This would have to be a 1. The only way to get this to an 8 is with that as a 1. Well, if that's a 1, then that's a 2, and that's a 4, then that's an 8, and then this doesn't get to be an 8 anyway. So that's not an 8. Think about it again. The only way that could have been an 8 is if that was a 1, then that would make that a 2, 4, 8. There's no way that could have been an 8. So we get 7 or 9. That's what actually eliminates the 4. I thought we had to eliminate the 4 to get the 8. To eliminate the 8, we didn't. We now eliminate the 4 because 3 plus 4 is 7, and then it would be 8 or 10, and that's not possible. So no 4. This is either a 3 and a 3 is 6. 1 is a 7. 3 and a 5. Oh, so it could be 3 3s. So it could be 2 3s there and a 3 there, which makes 9. Or it's 3, 1, 2, 5, and 1. Yeah, that's pretty much options. I think that's the extent to which we can eliminate it for now. That's useful. Yep. Now I think we can look at this one. Kind of. Let's mark its options. It's a 1, 2, or a 3. Now, actually, I think, what have we got here? 1 plus, there is a way of eliminating something possibly here from here. 1 and 2 definitely here. With the 3, it would be 6. And then with the 3 there, it would be 9. Yeah, there definitely could be a 3. So that is a 1 or a 2 or a 4 or a 6. That's its options. It does make it blue, as its only options are in the lower side of the digits. So it's at least somewhat blue. You know, if it was 4, it would need to be red as well, but it's at least somewhat blue, which makes that one somewhat red. So we can go 4, 5, 6, 7, 8, or 9, because it had to get its blue from that red. Okay. Yeah. I think we don't get to eliminate. Now, I do know that we've got a 1, 2 pair and a 1, 2 pair here. I think that's how you do it, something else here. So there's a 1, 2 pair there. That's how you eliminate the 6. Yeah, you can do that. So there's a 1, 2 pair there, because that can't be a 1, 2. So that eliminates a 3 actually from here. That's a 1, 2 pair. That's cool because it's purely blue, which is cool. We eliminate the 6 as an option here. Now this is a 1, 2. Now, yeah, like this one. Yeah. So it rotates. So it would have had to have gotten its redness from here. Pretty sure. Yep. So that's a 4, 5, 6, 7, 8, or 9 to be blue in the first place. But it being purely blue means that this one here is that one's purely red. Yeah. So that one's 7, 8, or 9. All right. Yeah, forget what you do now. There's some more things we can do. I know there's some more things we can do around these center cells, and really, you have to do some work here. It doesn't look like you can do much, but you can. All right, let's look at these center cells. Let's just consider their color. Can this be purely cold? No, because as discussed, any purely cold, like what I mean is a 1, 2, or 3. Well, obviously it can't be a 3, but you're thinking, oh, well, that can be a 1, 2 pair. No, it can't. Because that purely cold would mean that that one was purely hot, as discussed before. There's no way that can be purely cold. So it's at least hot. It's a 4, 5, or 6, 7, 8, or 9, which makes that one cold. 1, 2, 3, 4, 5, or 6. And for the same reason, these two are, yeah, equivalent. 4, 5, 6, 7, 8, or 9. And this one. 1, 2, 3, 4, 5, 6. Yeah. Now, eliminates the 4th possibility from here and here. That's not a 4 possibility. We've got the 4 here and here. Yep. Yeah. Yeah. So, I forget how you do this now. I think there's not a lot we can determine about these until later. Oh yeah, middle cell. Yeah, this one has to be middly. That's 100% right. 4, 5, or 6. In fact, it's not a 4. It's a 5 or a 6. That's quite important. Yeah, that one's middly. Yeah, it has to be. There's no way about it otherwise. Yeah. Okay. Yeah, I think the rest of it gets a little bit slow going at this point. We've pretty much done everything we can do. I forget if we have to eliminate something else. I forget where we go from here. Forget if we can eliminate the 3 here now. No, we can't, I don't think. 1, 2, 3 is 6, 7. Yeah, no, we can't do that. Now, yeah, it's about now where I sort of get a bit, it gets slow a bit, and you've got to take it slow from here on. But I know there is more tricks to the middle that you've got to explore. I know that. All right. Well, here, I think this is the point. This is a 5 or a 6. So the question to ask is if these can be a 5 or a 6. And the answer is actually no, they can't be, but that's a bit of a spoiler. So in other words, can these be blue in any way? Okay. So let's consider that. Let's consider that possibility. Okay. If that's blue in any way, think about this. What I'm saying is this a 5 or a 6? Can these be a 5, 6 pair? All right. Well, let's consider that. 5 here, 6 here. Right. Well, then how did that get its blueness? The question is, how did that get its blueness? That would have had to have been it would have to be red here. They'd have to be red here to make that blue, which makes that a 4. Okay. Now, this is a, I forget how you do this. There's a way. Maybe I'm not supposed to do this yet, but by considering that possibility, you can, well, this would at least be a 3. So, oh yeah, hang on. That being a 4, you can't have 1 4 here to make 5. So you'd have to have 2 and 3 here somewhere. You'd have to make that a 2 and a 3 because that wouldn't be able to be a 1 anymore. This is a little bifurcated a little bit, but you can sort of see how the logic works here. Now, here's the thing. 4 plus what is 7? 3 can't be 3. 4 plus what is 8? 4 can't be 4. 4 plus what is 9? 5 can't be 5. So this cell is now broken. That's the general idea. So that was never able to be a 5. A little hard to see, I know. So that's not a 5. Could it be a 6? That's a good question. Let's just nick out the 5. Can it be a 6? Well, that would be a 5. And we got similar problems. So let's just, break down the problems similarly. That's a 7, 8, or 9. This is not a 5 or a 6. It's not a 5 or 6. The only way that could have been a 6 is, and it got its got its blueness, is if that one here was red, which again makes that 4. How can that one be a 6 without using a 4? Well, it can't be a 3, 3 pair, so it's a 1 and a 5 pair, or a 2 and a 4 pair. That one can't be 6. 1 and 2, that would have to be a 5 or a 4, neither of which are possible. So this one can't be 6. Hey, so actually, this one can't be 5 or 6. It's actually purely red. And if it's purely red, this one has to be purely blue to make sure it stays purely red. Now, you can ask the same question about this one. Can this one be 5 or 6? And actually, it's the same thing. I mean, I could go through it again. 5, that makes that 6, makes that one 4. That one can't be 1. That would have to be a 2 or a 3. I'm recording. And that one is either a 3, which it can't be, to make 7, a 4, which it can't be, to make 8, and a 5 to make 9, which it can't be. None of those options are possible, so this is not a 5. This is not a 5. Same with, is it a 6? That would have to be a 5, that would have to be a 4. Again, to give it its blueness, make that one red to make that one blue. This doesn't work again, same reasons as before. How could this be 6? It would need a 5 with a 1 to make it 6, or a 4 and a 2 to make it 6, or 2 3s, and that's all of those are bogus. So nope, it can't be a 6. It's the same thing. It's the same thing twice. So that's also purely. That's actually purely, we actually got a triple here, I'm just going to show you that in a second. That's purely red, which makes that one purely red, purely blue. That's purely blue here. And it's at this point you can do some really cool things, because you got 1, 2, 3 here. That's a 5. It's red, to make it sort of mixy red. That one there causes that one to be blue, which means that one is 4, that one is 2, that one is 1, that one is 3. Yeah, there you go. That one is 6. That's not 1. These are not 5. In fact, how can you do this one up here anymore? I think I've, we've got it. So we're going to do, so that's a 3, and that's a 3. This has to be a 3 as well. There's no way it could be a 5. So that's purely, it was possibly a 5 before. Now it's purely blue, which makes this one not be able to be middly in any way. Rotationally, there could never be blue here anymore. So that's actually a 7, 8, 9 pair, 7, 8, 9 triple here. So many things are starting to happen now. That's right, that one's not 7, 8, or 9. This one is actually middly, which meant that this one needed to be hot to give that one its blue. I'll come back to that in a minute. Now, here's the thing. These being purely hot, 7, 8, or 9, the rest of these have to be from 6 or less, so they're at least somewhat blue. All of them. 1, 2, 3. And same with this one. We've got actually a 1, 2, 3 triple here. So at least these are at least red, and they're actually just the reflections of each other. So that these two reflecting here and here, and that one reflecting there. These get the monikers of 1, 2, 3, 4, 5, or 6, but you can see there's a lot of cancellation out here. These can't be 2 or 4 or 6. This can't be 1 or 2 or 4 or 6. There you go. These have to be 4, 5, 6, 7, 8, or 9. You can see that one can't be 5 or 6, 5 or 6, 5 or 6. Now, same with this. This is 7, 8, 9 pair. So this is not 7, 8, or this is not 7, 8, or 7, 8. Apparently it's not 3 either. We're really honing in on this one. In fact, we've honed in on it. This one is middly. It's more than one way of figuring that out. Middly, marking as middly. It would have gotten its blueness from a red one there. In fact, this is a 1, 2, 3 pair. All of these are red. So 1, 2, 3 here. These are all at least red. So you can see that. And this red one, well, yeah, it's the same. 3 reds here. All of these are at least blue. So we're moving on. That's not a 3. Apparently, yep, it's not a 3. Yeah. Forget, it's getting a bit messy now, but we'll go 1, 2, 3, 4, 5, 6. That's cool. Let's have a look at this. We've just eliminated heaps from here. So that's a 4 and a 1 makes that at least a 5. So that one's not a 4. 6 and 6 and 2 could make 8. 9's not possible anymore. Or is it? No, yeah, 9 is still totally possible. 5 and 4. No, that's as far as we go with that one, I think. There might be more to it than that, but yeah. Let's mark up these ones. It does have to mark 4, 5, 6, 7, 8, or 9. 5 and 4 eliminated from here. That's pretty much okay. Oh, 5. Yeah, how could this be a 3? 5 plus 3 is 8. Sorry, 5 plus 3 is 8. Plus, like, 1 is 9, plus 1 is 10. There's no way that could be a 3. No, it can't be a 3. This is a 1, 2 pair. So we got 1, 2, which is 3, plus 4 is 5. That makes that a 1. It's the only possibility, I think. And we've got 2 there and 2 there and 9 there. Maybe we should look back at these. Oh yeah, there is something back at those again. Oops, I eliminated too much there. Just kind of want to mark up everything. 1, 2, 3. Yeah, 1, 2, 3, 4, 5, 6. Not 1, 2, not 4, 5. That's a 3 or a 6 only. That's cool. Now, let's have a look at this one. 7 at least, with the 3 at most. 3 plus 4. It's at least a 4. 7 at least, 3 at the most. 3 plus 4. That one at least has to be somewhat red, which makes that one. Makes that one blue. Same with this one. 7 at least, 3 at most. This one needs to be at least 4. So it's a red, and that one's blue, and we get this pattern. So this is a 1, 2, 3, 4, 5, 6 situation here. 2, 3 is out. Wait, no, it's not. 2, 3 is out from there. 1, 6 is out from there. This one here is 4, 5, 6, 7, 8, 9. No way, it could be 9. 6 is a possibility. Okay, 3, 4, 5, 6, 7, 8, 9. 6 is out as a possibility. Oh, here. I forgot. 3 and 3 plus 3, that's a 9. Yeah, that's not a 9. There's no way that's a 9. 9s are out here and here. 4s are out from there. Always has been. 5 Yeah, I think we're getting down to the end now. We've got, I forget where we're going from here. Can this be a 4? Yeah, if it was a 3, could it be a 5? Yeah, certainly. 7 with a 3. No, that's going to can't be 7. Oh wait, 7 and a 2 can make 9. Can it be an 8 and a 2? No, it can't be 8. That's not 8. That's right. That's cool. Let's have a look at this one. Can this one be 8? 8 and 1 is 9. Yeah, 7 and 1 is, yeah. What's not possible? That was 3. No, if that was, yeah, I'm not sure. I'll leave it. I think that's fine. These are these are purely blue. Yeah, I think we're good. 3-5 pair in this one. We actually get a 1 here, which is really cool, because that means that one can't be middly. So that's 7, 8, or 9. So we'll look at our 7, 8, 9 situation here. I don't know how you will. I think. Yeah, I don't think there's a way of disambiguating which ones are 4 and which ones are 8 yet. Oh, yes, there is. Now that that's a 2. Sorry, yeah. Now that that's a 2, purely 2, this one can no longer be a 4. Because how would it get its blueness if it was 4? This one is an 8. Sorry, that's an 8. That's a 4. Yeah. And that's really good because we actually get all of our purely red digits now in this column. Oops. That's not an 8. Could be good to look at later. These being purely red means that one has to be purely blue. Because how else could it? If it was 5, it would give this blue. Like if it was somewhat hot, it would give this one blue. So it can't do that. So it must be 3. That's 5. That's at least somewhat red. It gets that redness causes, yeah, that one to be blue, which it is. And we're good. I think we're going alright. We're going to take out the 4 from there. Take out the 1s from here is interesting. I think I already made it less interesting though, because I already just got rid of the 5 out of that. So 2 plus 6 at a minimum is 6. Yeah, that's at least a 6. So we'll keep looking at this. This is still interesting down here, I believe. 4 at a minimum. This one can't be 6, otherwise you'd go too far overboard. So that's a 2, 4, or 5. I don't think there's any sort of restriction on this one being anything yet. No, I don't think so. I get a little bit lost again, probably. Try and remember where I'm up to. It might just pay to, yeah, here we go. I've already got mine all low digits here. These are all hot digits. And it's important just to mark them as such, 4, 5, 6, 7, 8, or 9, because yeah, that's going to make a whole bunch of other digits cold, aren't it? So I think I just marked those ones up. And yeah, I mean, it's these ones here. These are all cold. That's quite right, because no, that's not right. So let me just double check that. This one is that one. That one's that one. That one is that one. That one is that one. Yeah, that is right. Actually, the more to the point is, remember that 1, 2, 3 thing? This cell here makes that one not be able to be 4, 5, or 6. That one couldn't be 4, 5, or 6 because it's counterpart to that side. This one can't be red. This one cannot be red, so it can't make that one blue. There's no way that one can be blue. That's a 4, 5, or 6. We've got our 4, 5, or 6, 7, 8, 9 here. We've got a 1, 2, or 3 here. The rest are actually middly. These are all 4, 5, or 6, which actually means they're all red. So that one translates to here. That one translates to here, and that one translates to here, and we get even more digits. Can't be 1, 2, 3, 4, 5. Can't be 5, 6. Yeah, 3, 4, and 6. Yeah, okay. I think that's what we got. I'm trying to see if we got any triples here again. I forget whether or not we have. It might just pay to just say where does 3 go in that column. Oh no, it could go there or there. In fact, there is a 3 down here. That is for sure. So if we mark 3 anywhere, no, of course we haven't. 6 can go anywhere. 4 can go lots of places. Yeah. Yeah, we're fine. Where does 1 go? Yeah, it could be anywhere. Yeah. Okay. Ooh. Yeah, it gets a little bit tricky to see through at the moment, but we're getting there. It can be useful at this point, maybe just to mark these as green instead of the red-blue thing, but I don't know. We'll keep going. Yeah, I'm not sure. This is a 1, 2 pair here. I hadn't noticed. That's not a 2. That's not a 2. Great question now is where 2 goes in this whole arrangement of things. Can't go here. There's a 2 pair, so I can't go there. It's not those. It's not there. That's the only place for a 2. Makes that a 1. That a 2. Very useful. That's a 1. That's a 2. That's a 3. Just eliminates 3 as a possibility from there. That's really good because we just made these ones not purely cold, which means they must be at least a little bit red. Now, I've got to highlight them just somehow so I can remember them. They're at least red. So we got blue. That red caused that to be blue, which means it's no longer 7 or 8. That's good, thank you for that one. And this one being blue causes this one to... No, sorry, causes that one red causes this one to be at least somewhat blue. Can't be 3. 3, no, it can't be 3 either. Where can it be? We have 3 from down the bottom. So actually, 4, 5, 6, we got a digit. This couldn't be, yeah, we got a digit. That's a 6. 30 digit, it can be. Which means it's a little bit red as well. That redness casts some blueness down here. So this one can't be 7 or 8. And hopefully you can see how this just works its way around the board. That's a 5 or a 6. Could be useful. That one's not a 6. You got a 4, 5 pair here, which means that one is our 6. Oh, this is huge. That one can't be 6. That one can't be 6. This is purely hot. Now, now that's purely hot. Now let's eliminate some more 6s here. 6, 6. That one being purely hot means that one cannot be any way red. That one cannot be in any way red because that would make that one somewhat blue. And it's not. It's purely hot. Which means that's a 1. This one is not a 1. That's a 4, 5, or 6. Beautiful. That means it has somewhat got some red in it as a middly digit, which causes some blueness there. 4, 5, 6. Actually, looks like we've somehow... Oh, yeah, 6 up here. We got 6s. Oh, look at this. We've actually got a 4. We got a digit up here. That's a 4. That's not a 4 or a 6. It's purely red, which means that one can't be anyway red. It's got to be purely blue. That's a 2 or a 3. We've got 4s out of all of those. 5, 6 pair. No 6 here then. No 5, 6 pair there. We're getting good. We're getting good. We got all of our middly digits here. 4, 5, 6. Yeah, 5, 6 pair, no 5 here. That's a 1 or a 3 only. This is purely blue. In fact, both of these are purely blue now, so that one can't be a 6. Where does our final 5, 6, or 7 come from? Can't be any of those. Probably, I mean, looking at that, we've got some sort of quintuple or something like that. That one can't be a 4, in other words. Yeah, that's purely red. That's good, because that means this one can't be 5. Yeah, otherwise it would be cause some blue over there, and it can't have blue, so that's a 2. We've got all of our purely blue digits down here. This remaining one must be red. That one translates to here, which puts blue here. It eliminates a 7, 8, or 9. It makes it 4 only. That looks like we get a 2. Where did we get? Oh, we got a 2 down here. That's a 3 in the corner. That's a 1. That's not a 4. That's a 2 or a 5. Looks like we got 3s out of here, 4s out of here. We're going well. Okay, we got our 7, 8, 9 triple here. This one is a 4, which means it has blue in it, and that blue had to come from somewhere. It looks like it comes from here. Yeah, that one's at least somewhat red. Let's mark it. 4, 5, 6, 7, 8, or 9. Can't be 4 or 5 or 8, sure. It looks like we've eliminated all but one possibility here. That's a 5. That's a 4. 4, 5. That's a 7. We get a 2, 7. That's a 9. That's an 8. That's a 1. 8 plus what is 3? That's a 5. That makes that a 4. We get, let's just fill in some basic ones that don't cause too many complications. Let's eliminate some possibilities over here that don't matter. There we go. And let's eliminate this one now. Seeing though this one can't be a, whatever it can't be now, it's a 6. It has to have red in it. Has to be at least somewhat red. That one gives that one a 4. This somewhat red one though makes that one at least somewhat blue. This is a 3. That's purely blue, which causes this one here to be purely red. 7, 8, or 9. Oh, what am I doing? 7, 8, or 9. Did it again. 7, 8, or 9. Not 8. So it's a 7, 9. Yeah, we got a 7, 9 pair. Of course we do. Well, that is good. 7, 9 pair causes this one to be, yeah. We'll just fix in a few things here. That's a given 5. Let's put this one as a 6 that it is with the 7, 9 pair. It means it's got blue in it. That blue has to have come from somewhere. That blue would have had to have come from here. It's red. In fact, it's the only purely red cell available left to us. So it is a 7, 8, or 9. That's because it came from here. Sorry, the no blueness came from the fact that that's a 2, which is also a given at this stage. That's good. This is a 3, 6 pairs. Is the only options left. Oops, 3, 6 in the box I'm looking at, but apparently it can't be a 3. Yeah, so that makes it a 6. Okay, cool. That's a 6. It means it's got red in it. Okay, where we're up to, let's just keep making deductions. No 6 here. That makes that a 5. That's not a 6. That's a purely hot digit. Therefore, I can conclude that this one had to be purely blue. Actually, there was more than one way of concluding that. That is definitely a 3. This one here is definitely a 6 Nope, definitely a 3, begging your pardon. That's interesting because that's one of our last little deductions that we're going to be able to make here. That one being purely blue means this one is purely red. 7, 8, or 9 here, not 9 apparently. Which means we got a triple E of 7, 8, 9 here. This is a 3. Yeah, it is, and that is a purely blue digit, which tells us that this one is purely red, not a 6. That's a 7, 8, 9 triple here, no 7, 8 there. That's a 5, 6 pair in some way. In fact, that does mean these are middly, they're both blue. Where did they get their blue from? They got their blue from here and here, which I hadn't marked yet. Yeah. And that's pretty much, we got the whole world is marked out here, or nearly marked. We need one of these to be a 6. We're getting there now. Okay, that's a 5, 6 pair. That's not a 6. That's a 7, 8 pair. This is a 6, which means it's middly. And that there is a middly digit, so it had to have got, I've just put blue in there, didn't I? Yes, I just put blue in there, so its blueness came from the fact that that one was red. It's just something I hadn't marked from before, so some of my deductions I hadn't quite, marked across. We're getting there very much so. I know we're at the end here. I have a deadly pattern here that I'm very, very, very aware of, except it's not deadly because of this here. And we are in the end game, and the end game is quite fun because we have, now this one, what can it not be? This is the final deduction. 5 plus 2 is 7, 5 plus 6 is 8. There's no way that can be a 9. That's very important to know because now we have a skyscraper. We have the following. There is a skyscraper there on 9s. So bear with me. Basically, one of these two has to be a 9, I believe. So we either no, both of these could be theoretical. No, that's not true. That's a load of rubbish. There has to be a 9 here, and there has to be a 9 here. Where are the positions for those 9s? It's either there or there, or there or there. Now the thing about that is it's actually one of these two that has to be a 9, I think. Because if that's a 9, then that's not a 9. Yeah, I forget how this works. I really do sometimes. This is complicated. How do I explain it? That one, if that one's a 9, then that's not a 9. No, forget that. Forget this. Screw this. It's kind of complicated. Let's put it in. If that one's a 9, that one's not a 9. Okay, fine. But if that one's a 9, well then that's a 7, and then that's a 9, and that's not a 9 as well. So that's basically how you do it. Basically, one of these two has to be a 9, therefore forcing a 9 out of that. And basically that's a 7. That's how we do it. That's a 9. Here we go, and let's just do a 7, 8, 9, 8, 7, 8, 7, whoops, 7 here, 7 here, and 9 here, and 8 here, and 9 here, and 8 here, and this makes that a 7, which kills the deadly pattern. We'll just finish off our 8s and 9s. This is 9, and we get a 2 plus a 5 is a 7, and that's a 6, and that's a 5, and that's a 6. And my solve time is horrendous, but I've solved the puzzle and the solution is correct. Yay! Hopefully that's making sense. Yeah, that is the correct solution. If you wanted, we could do all the 4s, how do we do this? All the 5s and all the 6s, and do some sort of other digit, other colour, and say they're middly. And that would be the solution. Yes, there you go.